Hi everyone. So you've seen a few examples with the product rule, and this would be a great time for you to pause and try number 3 on your own, and then just check back in, make sure you got it right. Okay, so we're first given function m of w equals 3w to the 17 times 4 to the w, and we're supposed to find its derivative. So the 3, you can kind of do what you want with. You could consider it completely separate and multiply your entire derivative by 3, but I think it's easier just to mentally hook it to the first factor, and then you can use the constant multiple rule within your product rule. So this is definitely big operation product. You do exponents first, the last thing you do is multiply. So we're going to do the second, 4 to the w, multiplied by the derivative of the first, and the derivative of 3w to the 17. Let's see, the 17 drops down in front, we get 30 and 21, 51 w to the 16. And then we need a plus the first, 3w to the 17, multiplied by the derivative of the second, which is going to be a 4 to the w multiplied by the natural log of 4. So that actually doesn't look bad as it is. If you'd like to, you can do the factoring for practice. Factor out a 4 to the w, and we're left with a 51 w to the 16 plus 3w to the 17. Oh, I'm being silly. Times the natural log of 4. If you're going to factor, you could also factor out w to the 16 and a 3 even. You could factor out a whole bunch of stuff. So I just factored out a 4 to the w, but you could do even better. Okay, second one, we're given sine t plus cosine t times t to the 4th. So here again, big operation is the last thing you do. So we do everything in the parentheses, we do our exponent, and then we'd multiply. So this is a product rule. My first is all of this, and my second is the t to the 4th. So h prime of t is going to be second, t to the 4th, multiplied by the derivative of the first. So we're going to get the derivative of sine, which is cosine, plus the derivative of cosine, which is the opposite of sine. Okay, and then we need a plus the first times the derivative of the second. The derivative of t to the 4th is 4t cubed. Okay, so let's see, simplifying this thing, I'm sort of undecided. We could factor out a t cubed. I think I might just distribute everything through this time. I don't see anything particularly nice happening. So I'm going to say I end up with a t to the 4th cosine t minus a t to the 4th sine t plus a 4t cubed sine t plus a 4t cubed cosine t. Okay, so you can factor out stuff if you want as well. Again, that's optional, but this form that it ended up in, where it's a sum but there's factors within the terms, that's not a great simplified form. For part C, we're supposed to find the slope of the tangent line to the curve y equals f of x at the point where x equals 1, and our function is e to the x times sine x. Okay, so slope of the tangent line comes from the derivative. So the very first thing we should be doing is finding the derivative, f prime. And I have my first is e to the x and my second is sine x. So this is going to be the second sine x times the derivative of the first. The derivative of e to the x is e to the x, so that's an easy one. And then plus the first, e to the x, times the derivative of the second. Derivative of sine is cosine. So there's my derivative. And I'm interested in the slope when x equals 1. So we should be plugging 1 into the derivative. And nothing particularly nice happens there. Here, I'm going to go ahead and factor out the e to the x. Don't have to, but I just think it looks a little nicer here. Okay, so e to the 1 is just an e. Sine 1 is what it is. Cosine 1 is what it is. Those aren't particularly nice, so that's your answer. The slope of the tangent line is e times sine 1 plus cosine 1. Okay, and then last part here is find the tangent line approximation. Oh, I'm trying to catch all this wording. If you see this anywhere, I'm trying to change it all. It just means find the equation for the tangent line. It's just a little different wording. To the function g of x when x equals -1, if g is given by x squared plus x, all multiplied by 2 to the x. Okay, so the equation for the tangent line will need the slope just like before. So let's go ahead and take the derivative. G prime is going to be the second, 2 to the x, multiplied by the derivative of the first, which is a 2x plus 1, and then the first multiplied by the derivative of the second, which is a 2 to the x times natural log of 2. Okay, and we're supposed to figure out the tangent line when x equals 1. So let's find the slope by plugging, -1 into our derivative. Okay, so we get a 2 to the -1, which is the 1/2. And then we get 2 times -1, -2 plus 1, which is -1. And then -1 squared is 1, plus -1 is 0. So that actually wipes out all of this. So plus 0, which means my slope is -1/2. We also need a y value. So let's go back to the original function g and plug in our -1. And we get -1 squared, which is 1, plus -1. So actually we're getting 0 again. 0 times 1/2 is 0. So my point is -1, 0. Okay, so if we put it all together, y minus 0 equals our slope, -1/2 times x minus -1, which is an x plus 1. So y equals -1/2 x minus 1/2. All right, thanks for watching.